Alright, today we're going to take a look at the cosecant function. So if you remember, we have sine, cosine, tangent, and their reciprocal functions, cosecant, secant, cotangent. Now we're dealing with sine and cosecant today. So these are reciprocals of each other. And really what we're going to do in order to graph the cosecant function, we're going to graph first the sine function. And so if you remember, sine starts at the midline, and then it goes up from that midline as we go to the right, and then we go down following that same pattern as we go to the left. Now, I'm going to try to do this as kind of a dotted line. Oh, I totally messed that up. And now what we're going to do is find everywhere we see in the midline, we're going to find and draw a vertical asymptote everywhere our original sine or cosine crosses that midline. And then we're going to find the maximum or the minimum of each of our sine and cosine function, and then we're going to now connect these in such a way where it's not really a parabola, but we'll just call it a parabola, a U or an N-shaped graph, where the minimum of this N-shaped graph goes through the maximum of the sine function, or the maximum of this N-shaped graph goes through the minimum of the sine function. And this, what we're graphing here, or drawing in red, is our cosecant function. And so when we're graphing cosecant or secant, we're going to first graph sine or cosine, and then draw what the secant and cosecant would be as a result. And how we do that, we're just looking for the maximum or the minimum of the sine or cosine function, and then connecting those with a U or an N-shaped graph. Let's take a look at an example where we're going to have a little bit more movement. So here, we still have an amplitude of 1, right? We don't normally write 1 there, but we have an amplitude of 1. Here, plus 2 means that we're going to go up 2. Now this is our b, right? And so our period is 2 pi over b, which in our case is 3. There's no shifting left or right, but there is a shift up. So let's go ahead and take that shift up, and we're going to go up 2, and this becomes our midline. Now, we have an amplitude of 1, so I'm only going to go up 1 more for my max and down 1 for my min. Now, because this is cosecant, let's first figure out, okay, what is our sine function? Let's kind of graph the sine of this. Sine would normally start at the midline, and that would normally be here at the middle. Now, we have no movement left or right, but let's draw our tick marks anyway, or label our 4 tick marks. So our period, our 4th tick mark is 2 pi over 3, and half of that, technically remember when you multiply by half or take half of something, you're multiplying the denominator by 2. So this would be 2 pi over 6, but that reduces to pi over 3. Half of pi over 3 would be pi over 6. And then when I multiply pi over 6 by 3, I would get 3 pi over 6, but 3 over 6 reduces to 1/2. And so here would be our tick marks. Now, the sine function would then go up every tick mark from there and following our pattern. And as I would connect our sine function, I'm using a dotted line because that's not really what we're trying to graph. Our whole point and purpose here is graphing the cosecant function. Let's get a different color for the cosecant function. What I want to do is find my midline and find every point that crosses at that midline. And what that's going to do is it's going to show me, hey, this is where you need to draw a vertical asymptote. In this case, it's the y-axis. And then from here, I now need to find every place that I have a maximum or a minimum. And then I'm going to draw my U-shaped or N-shaped graph that goes through that maximum or minimum, understanding that these arrows I'm drawing at the end are never going to cross these vertical asymptotes. They're always going to stay in between these vertical asymptotes. And so that is our cosecant function. So anytime we have any kind of transformation, we're going to pretend like it is sine or cosine respectively. And then once we draw that, Then we will focus on the reciprocal function, and if you have multiple colors, then you can use a different color to show that, or you can just do the dotted line as I did for our sine and cosine.